Okay, in this lesson we are going to solve mixture applications. Okay, so you probably haven't thought a whole lot about how you count money. You probably just do it. You don't even think about it. So let's say that you have 10 nickels. So I want to know how much that is. 10 times 0.05 is 50 cents. Just remember that you take the number that you have times the value of the coin gives you your total value. Okay, for this problem, Adalberto has $2.25 in dimes and nickels in his pocket. He has 9 more nickels than dimes. How many of each type of coin does he have? So we want to look at what we're dealing with here. We're dealing with dimes and nickels. So I'm going to let D equal the number of dimes, and I'm going to let N equal the number of nickels. Okay, and I know that he has $2.25 in dimes and nickels. So if I have, let's see here, how much is a dime worth? We've got 0.10 times the number of dimes plus 0.05 times the number of nickels, and I know that that total is $2.25. Alright, so something else that I know. Okay, it says here he has 9 more nickels than dimes. So let's see here. So he has more nickels than dimes, so you take the number of dimes and you add 9 to it to get the number of nickels. Okay, so I've got this equation and I've got this equation. Now, how do I use these two equations to help me figure out how many dimes and nickels that I have? Well, check this out. If N is equal to D plus 9, then wherever I see N in the other equation, which happens to be right there, I can put in D plus 9. So my next equation will look like this. 0.10 times D plus 0.05 times, instead of N, I'm going to write D plus 9 here, equals 2.25. Now to solve this for D, I'm going to distribute. So I've got 0.10 D plus 0.0, oops, that's a 5. D plus 0.45, remember 0.05 times 9 equals 2.25. Now I'm going to add my like terms together. So I've got 0.15D plus 0.45 is equal to 2.25. Subtract 0.45 from both sides. And I get 1.8, or 1.80 if you want to write the 0 there. Divide both sides by 0.15. And I get that D is equal to 12. So that says that I have 12 dimes. Okay, so now how do I find the number of nickels? Well, I can take this D and I can put it right there to solve for my number of nickels. N is equal to 12 plus 9, so N is equal to 21. Now what you want to do is you want to make sure that 21 nickels and 12 dimes adds up to be 225. So here's what I'm going to do. I'm going to do 0.10 times, how many dimes do I have? I have 12, plus 0.05 times 21. And that number better be $2.25. So on my calculator, 0.1 times 12 plus 0.05 times 21, and I do get $2.25. So I know that I did this right. So I would say 21 nickels, 12 dimes. Alright, so for this problem we've got Maria has $2.43 in quarters and pennies in her wallet. She has twice as many pennies as quarters. How many coins of each type does she have? Okay, so let's define our variables. We have quarters and pennies, so we're going to let Q equal the number of quarters. And we're going to let P equal the number of pennies. Alright, so the first equation that we're writing has to do with the value of it. So quarters are worth 25 cents, so 0.25 times Q, plus pennies are worth 0.01 times P, and that total equals $2.43. Alright, I feel like that's the easy one to write. Okay, so the next one says she has twice as many pennies as quarters. So she has more pennies than she has quarters. So that means I'm going to take the number of quarters and I'm going to multiply that by 2 to get the number of pennies, because it says I have twice as many pennies. So I have to take the quarters times 2 to give me my pennies. Now, my P is equal to this business right here. So wherever I see P in the other equation, I can substitute in 2Q. So now I'm rewriting this equation, 0.25Q plus 0.01 times, instead of P, I'm going to write 2Q now. Alright, so now notice in our equation we only have one variable. We've got a couple of Q's, but we don't have Q's and P's anymore. That's a good sign. That means that we can actually solve for Q here. So now I'm going to just simplify. I'm going to combine my like terms. And now I'm going to divide by 27 cents. And I get Q is equal to 9. That means I have 9 quarters. So if I have 9 quarters, I double that to get my pennies. So I have 9 quarters and I have 18 pennies. And that's my final answer. Alright, for this problem, Danny has $2.14 worth of pennies and nickels in his piggy bank. The number of nickels is 2 more than 10 times the number of pennies. How many nickels and how many pennies does Danny have? Alright, so the two things that I'm dealing with are pennies and nickels. So I'm going to let P equal number of pennies. Oops. And I'm going to let N equal the number of nickels. And so my first equation has to do with the value of this. So pennies are worth 0.01, so 0.01 times P, plus nickels are worth 0.05 times N is equal to 2.14. Now that's my first equation. So now the next equation has to do with this sentence right here. So the number of nickels is 2 more than 10 times the number of pennies. So now check this out. N is equal to this business right here. So wherever I see N up here, I can put in 2 plus 10P. So I'm going to rewrite the top equation, and instead of writing N, I'm going to put in 2 plus 10P. And now I'm going to simplify. I'm going to distribute. and combine my like terms. Subtract 10 cents from both sides. Oops, there we go. Still messed that up. And divide both sides by 51 cents. So I get that P is equal to 4. So what does that mean? That means I have 4 pennies, or Danny has 4 pennies. So if I want to know how many nickels, I'm going to take this number, this 4, and I'm going to put it in for P right there. So I've got 2 plus, so the number of nickels is 2 plus 10 times 4. Alright, so this means that Danny has 42 nickels and 4 pennies. Okay, so for this problem, we're at a school concert. The total value of tickets sold was $1,506. Student tickets sold for $6 each, and adult tickets sold for $9 each. The number of adult tickets sold was 5 less than 3 times the number of student tickets sold. How many student tickets and how many adult tickets? I don't like to use S as a variable because it looks too much like a 5, or like my 5s anyway. So I am going to use X and Y here. So I'm going to let X equal number of student tickets, and I'm going to let Y equal the number of adult tickets. Alright, and I know that the value of this was, let's see here, student tickets sold for $6, so I've got 6 times X, that's the number of student tickets sold, plus 9 times Y is $1,506. So there's our first equation. Now I'm going to do this sentence right here. The number of adult tickets sold was, so the number of adult tickets, that's Y, was or is means equals, 5 less than, don't forget whenever you see those words less than, that means you've got to reverse the order, so it's got to be minus 5, then 3 times the number of student tickets, so that would be 3x minus 5. So now I'm going to take this right here, because Y is equal to that, and I'm going to put it in for Y right there. So I'm going to rewrite this equation, and instead of Y I'm going to put in 3x minus 5. Again, right here I'm distributing. And I want to combine my like terms. I get 33x minus 45 is equal to 1506. Add 45 to both sides. And I get that x is equal to 47. So what does that mean? That means 47 student tickets. So now I want to take this 47 and I'm going to place it in here for x. So y, or my adult tickets, is equal to 3 times 47 minus 5. So 3 times 47, 141. So y is equal to 136. So what does that mean? That means 136 adult tickets and 47 student tickets. Alright, for this problem, Galen sold 810 tickets for his church's carnival for a total of $2,820. Children's tickets cost $3 each, and adult tickets cost $5 each. How many children's tickets and how many adult tickets did he sell? Alright, so let's see here. What two things am I dealing with? So I'm going to let X equal number of children's tickets, and Y is equal to the number of adult tickets. And I know that together I sold 810. Alright, so now the next one is about their value. So this and this information is important. So the children's tickets, which are $3, plus $5 for the adult tickets, came to a total of $2,820. Now, you'll notice we don't have anything to substitute in. We need to have a variable all by itself. So here's what I'm going to do. I'm going to take this right here, and I'm going to subtract X from both sides. And I can't combine those. They're not like terms. So that's as good as it gets. So now I do have that Y is equal to this business right here. So wherever I see Y in the problem, I can put in negative X plus 810. So I'm going to rewrite this problem. And now I'm going to simplify it. Combine my like terms. And I get negative 2x is equal to negative 1,230. So what does that mean? That means that there were 615 children's tickets sold. So now we need to figure out how many adult tickets were sold. So I could take this X right here, and I'm going to put it in for X right there. So I've got 615 plus Y equals 810. Subtract 615 from both sides. And I get 195. So what does that mean? That means there were 615 children's tickets sold, and there were 195 adult tickets sold. Okay, so in class today I showed you another method for doing this problem. And so what I'm going to do is I'm going to erase a lot of this page. Here, I'll show you what I'm going to erase. Okay, so if you need any of this, you might want to hit pause right now because I'm about to start erasing. So hit pause and write things down. Alright. I want you to remember how many there were. There were 615 children's and 195 adult tickets. And I'm going to show you another way to work this problem. Alright, and I like this way better. It's called the elimination method. And so what you want to do is you want to eliminate either X or Y. So I'm going to multiply the top equation by either negative 3 to get rid of my X's or negative 5. And it doesn't really matter because you're still going to come up with an answer that will guide you to the next answer, to the other answer that you're looking for. So I'm just going to multiply the top by -3. Now where did I come up with -3 from? I wanted the opposite of that number right there. So check this out. Whenever I multiply each and every term by -3, I get -3x minus 3y equals -2430. I am just rewriting this equation right here. Alright, so now watch this. I'm going to add these two equations together, and whenever I add this and this, I get 0. That's what we wanted. We wanted to create 0 there. And now -3y plus 5y is a positive 2y. And whenever I add -2430 plus 2820, I get a positive 390. Divide by 2. And I get that y is equal to 195. Look at that. It's the same number as right there. Okay? Alright, so now in order to get the other number, I could take this number and I could put it in for y right there. So x plus 195 is equal to 810. Subtract 195 from both sides, and I still get 615 children's tickets. So that's just another way to do the same problem, and we came up with the same answer. Alright, last problem. Monica paid $8.36 for stamps. The number of 41-cent stamps was 4 more than twice the number of 2-cent stamps. How many 41-cent stamps and how many 2-cent stamps did Monica buy? Alright, so the two things that I'm dealing with, let x equal number of 41-cent stamps. I'm going to let y equal number of 2-cent stamps. Okay, and I know that 41 cents times x plus 2 cents times y is equal to $8.36. Now, it says the number of 41-cent stamps was, so x was or is means equals, 4 more than twice the number of 2-cent stamps. Okay, so now x is equal to this business right here. I can take this and put it in for x right there. So I'm just rewriting this equation. And I'm going to distribute. Combine my like terms. Subtract $1.64 from both sides. And divide by 84 cents. And I get that y is equal to 8. That means there were 8 2-cent stamps, and to figure out how many 41-cent stamps, I'm going to take this 8 and put it in for y right there. So I've got x is equal to 4 plus 2 times 8. So there were 20 41-cent stamps, and there were 8 2-cent stamps. Alright, there you go. That's it for this lesson. If you have any questions, let me know.